Welcome to ROS Fundamentals video. In this video, you are going to learn four key things. First, you will understand what ROS is and why it's such an important framework for building modern robots. Second, you will learn how ROS evolved from ROS 1 to ROS 2 and why today's systems rely on versions like Humble and Jazzy. Third, you will get familiar with fundamental ROS concepts like nodes, topics, messages, and actions. And finally, you will build a simple mental model of how robots actually use ROS to communicate, make decisions, and perform tasks. ROS actually isn't an operating system. Instead, it's more like a communication layer that helps different parts of a robot talk to each other. It provides tools, libraries, and a structure that make it easier to build complex robots. Whether it's sensors, motors, cameras, or algorithms, ROS gave us a common framework to connect all pieces together in a clean and a modular way. Robots are complicated systems, and ROS helps make them easier to build. With ROS, we don't need to reinvent basic features like message passing, hardware drivers, or sensor processing. They already exist. There's also a huge ecosystem of open source packages from navigation, perception, and others. Because of this, ROS dramatically speeds up development and is used by hobbyists, researchers, and industry. ROS started around 2010 and became the standard for research robotics. But ROS 1 had some limitations. It wasn't designed for real-time control, security, or multi-robot systems. So the community created ROS 2, a major redesign that fixes these issues. Today, ROS 1 is in maintenance mode, while ROS 2 is the future. Examples of ROS 1 versions include Kinetic and Melodic, with Noetic being the final long-term release. ROS 2 brought modern features like real-time communication, better security, and support for multi-robot systems. The most important ROS 2 releases are Humble and Jazzy, which are both long-term releases. ROS 2 is actively developed, more stable, and now the default choice for the new robotic projects. Humble, released in 2020, is extremely stable and runs on Ubuntu 22.04. Then we have Jazzy from 2024, which is the newest long-term version and targets Ubuntu 24.04. LTS versions are great because they are supported for many years. They get updates and the community focuses most tutorials and packages around them. If you are getting started today, Jazzy is a great choice. At the heart of ROS are nodes. A node is just a small program that does one job, like reading a sensor or commanding a motor. Nodes communicate using topics, which are like communication channels. A camera might publish images to a topic, and another node can subscribe to the topic to process the images. Messages are the data being passed around, for example, images, laser scans, or velocity commands. Beyond topics, ROS also includes services and actions. A service is used when you want to request and a quick response, like turning on a light. Actions are designed for login tasks, like moving a robotic arm. They can give progress updates. Nodes can also use parameters, which act like settings or configuration values. And everything in ROS is organized into packages, which bundle code, configs, and nodes together. ROS includes a number of tools that make development easier. RQT provides graphical debugging and introspection tools. RViz2 is a powerful 3D visualization tool that lets you see sensor data, robot models, and maps. Gazebo, now part of the Ignition project, is used for simulation, letting you test robots virtually. And Colcon is the building tool, used in ROS 2 to compile and organize your workspace. Think of a robot as a team of small programs working together. The camera node sends images, another node analyzes those images, a planner decides on the next motion and the motor driver carries it out. All of these nodes communicate through topics and services. This modular approach allows developers to swap or improve parts of the system without rewriting everything. This is one of the biggest strengths of ROS. ROS is used in many types of robots. Mobile robots like warehouse AGVs use ROS for navigation and mapping. Manipulator arms use ROS for motion planning and control. Drones, research self-driving cars, service robots, and even humanoids all have ROS-based systems. Because ROS works across hardware, simulation, and cloud platforms, it's incredibly flexible for almost any robotics project. ROS is supported by a huge community of developers, researchers, and companies around the world. There are thousands of open source packages you can reuse, and many universities teach ROS as part of their robotics curriculum. ROSCon is a yearly conference where the latest advancements are shared. This community support is one of the biggest reasons that ROS continues to grow and improve. Here's a quick comparison. ROS 1 uses a custom communication system, while ROS 2 uses DDS, an industry standard protocol. ROS 2 supports real-time control, security, and multi-robot communication, things that ROS 1 struggled with. While ROS 1 was groundbreaking, it's now mostly in maintenance mode. ROS 2 is where new features and packages are developed, and it's the recommended choice for new projects. If you are starting ROS today, I recommend using ROS 2 Jazzy, especially if you are running Ubuntu 24.04. It's the newest long-term release, and it will stay supported for several years. If you are on Ubuntu 22.04, then ROS 2 Unbolt is still an excellent option. Choosing the latest LTS means you get the most reliable software, the most tutorials, and the most community support. To go deeper, you can start with the official documentation at docs.ros.org. There are step-by-step tutorials for both Unbolt and Jazzy. Platforms like the Construct offer hands-on training and simulation. You can also explore GitHub projects to see real robot code. And if you have ever get stuck, ROS Answers is the best place to ask questions and get the help from the community. This is the end of the video. Thank you for watching.